passed out to you guys this little packet. We are not going to be doing this entire packet today, so yay, right? Okay. But what we're going to talk about today are, oh, I need one more here for you, don't I? We're talking about patterns. Sorry, Reagan. All right, we're talking about patterns. Specifically, okay, arithmetic sequences. All right? So you guys have been learning about patterns since you were little kids. You know what I'm saying? Like, that's kind of just like how we learn things, right? We see repetitions and we kind of like associate them and, oh, well, you know, maybe this pattern will continue and like make predictions and all that kind of stuff too. Okay? You'll see why we're doing this in the equations of lines section, okay, this unit in a little bit, but for right now we'll just stick to what we know. Okay? There's many different kinds of patterns. Some patterns don't have names, right? Sometimes they're just like things you just see the pattern and you just figure out the rule, and that's how you know what the pattern is. Some patterns though occur so regularly, that is, like, you see this kind of particular pattern so often that they have names. Okay, so that's what we mean when we see an arithmetic, okay, sequence. Now, yes, arithmetic, it's spelled the same way as the word arithmetic. But because we're using it as an adjective here to describe sequences, we say arithmetic, okay? So you could say arithmetic sequence, that's fine, but I'm going to say arithmetic, okay? That's why it's the same word as arithmetic, like it's the same, thing. Sometimes you just pronounce it differently, that's all. Okay? So a sequence, okay, let me just talk about what a sequence is. A sequence, okay, is a list of numbers. Okay, a list of numbers. That is a sequence. Wow, I wrote that really small. Okay, a sequence is just a list of numbers. So if you see a number, a list, so you can look down here, right? A, B, C, D, E, F. These are all sequences because they're just lists of numbers. Okay? But like I said, today we're talking specifically about arithmetic sequences. Okay? So what makes an arithmetic sequence an arithmetic sequence? Okay? An arithmetic sequence is a sequence where the difference between consecutive terms is constant. All right, there's a lot of fancy words in there to describe what this means. Okay, a sequence where the difference between consecutive terms is constant. Okay, so let's break this down. Okay, difference in math means what? Subtracting, right? Okay, so the difference, that is, if you subtract consecutive terms. What does consecutive mean? Continuous? Partially, yes. Partially, I'd say continuous. Okay, they are continuous. But consecutive, like when you're counting, what is the consecutive number to like 5? When you're counting, what's consecutive to 5? 6. What comes after 5, right? And so consecutive just means like what comes next, okay? The next term, okay? And so the difference between consecutive terms is constant. What does the word constant mean in math? Or in life, right? The same, doesn't change. So in other words, if you pick any two terms in order, right? Any two consecutive terms, so terms that are next to each other like this, okay? That means, and you subtract them, their difference should be the same, okay? And that would make an arithmetic sequence. All right, so let's take a look here at letter A. Okay, 5 minus 4. What's that? 1, right? Okay, so the difference here is 1. So I'm going to say to get from here to here, we have to add 1, right? From 5 to 7, it's plus 2. Do I need to check any further to see if this is arithmetic or not? No. Is it arithmetic? No, it's not. Why not? No, it's not. Why not?
Because it's not consistent.
Right. The difference.
Right. The difference is not constant.
Okay.
Okay. Difference is not constant.
Okay, and you don't have to give the reason. Just as
Okay, and you don't have to give the reason. It just says identify whether it is or isn't. Let's take a look at letter B.
What's the difference here from negative?
What's the difference here from negative 93 to negative 20? What's that difference?
That's not gonna work out. I could just wait a minute, hang on.
What's the difference between negative 93 and negative 20?
What's the
How do we
difference
figure
between
out?
negative 93 and negative 20? How can we figure it out? What can we do?
Negative 93 plus, I mean,
Okay,
plus
we can do it that way. We can also
Okay,
take your second
we can do it
term,
that way. We can also just take your second term, negative 20, subtract the negative 93.
73.
Find the difference. So the difference is 73. So to get from here to here, it's 73. Although what you said, Sean, would also yield a 73 too.
To get from
Okay,
here
so
to
plus 73. To get from here to here,
if I take that negative 20
I'm going to add, let's see, if I take that negative 20 and add 73,
that worked. Let's see if it works
53.
again.
Yep, that worked. Let's see if it works again.
Yep. Are you gonna check
126.
one more here to see if
Yep.
it still works?
Or you got to check one more here to see if it still works.
So,
And
can
it
we
does.
assume this sequence is
So
arithmetic?
can we assume this sequence is arithmetic then?
Can we assume this sequence is arithmetic? Yes.
Can we assume this sequence is arithmetic?
yeah.
Yes.
Okay. Arithmetic.
Okay. Arithmetic.
73.
Okay, the common difference is 73. Question.
Are we gonna like summarize arithmetic? Because I don't think I'm going to remember how to spell that. So like,
We'll
not
just put like
A,
yes, no.
Oh, I see what you're saying.
yes, A.
You're not gonna remember how to spell it.
Oh, I see what you're saying.
It's right there.
You're not going to remember how to spell it. Well, I mean, it's right there
Not there.
in the directions. If it's not there, then I'll help you out and spell it as best you can.
Can you spell
Okay.
arithmetic?
No, I'll have to figure it out.
Arithmetic?
So if you get stuck, I'll be happy to help you. But if it's
So if you get stuck, I'll be happy to help you, but if it's not in the directions, okay? I'll be happy to help. I understand what you're saying, though. But I do want you to try and spell it out, just because, you know, we should be able to write out the words and
Okay,
stuff like
let's
that.
take a look at the next one
Vocabulary
here.
is important.
to go from 3 to
Okay, let's take a look at the next one here. To go from 3 to 6, what can we do?
Plus 3.
Plus 3.
No, wait, like
Right. So if I
this one
yeah.
is,
So that's so I have to
Right, so if I, yeah. So I have to do times 2, times 2, times 2, times 2. If I multiply by the same number every time, is that an arithmetic
Let's go back up here
sequence?
to arithmetic. It says it's a sequence
Let's go
where
back
the
up here to arithmetic.
Sorry?
It says it's a sequence where the difference, sorry?
It's not the same numbers that you're like the numbers are all different, and then you're multiplying by itself, multiplying by difference.
Okay, so the key word here in arithmetic.
Okay,
is
so the
difference.
key word here in arithmetic is difference, which means subtraction. So if I do 6 take away 3, yeah, Dylan, go ahead. 6 take away 3, it's 3. But 12 take away 6 is 6.
12, 24,
Okay?
plus
12 to 24, that's plus 12. 24 to 48 is plus 24. Is this arithmetic?
Correct.
No.
That is a pattern, right? It is a pattern.
Correct. That is a pattern, right? It is a pattern. Okay? Yeah, if you need Simon, do
It
you
is
want
a
to go
pattern,
this
and it's got a name. We're not
Okay.
going to learn it right now.
Um,
We'll learn
It is a pattern, and it's got a name. We're not going to learn it right now. We'll learn it a little bit later, okay? But there is a name for it, okay? It's arithmetic, though. If you guys remember, way back in the first unit of this class, we talked about 3 different kinds of relationships. We had linear, quadratic, and exponential.
same number every time.
This is one of those 3. When you multiply by the same number every time, do you remember which one that was?
It was exponential. That's right, Sky. Very good. Okay. This is an exponential.
It was exponential. That's right, Sky. Very good. Okay? This is an exponential relationship. Okay? Also, the pattern, the sequence is called geometric because you would multiply by the same number every time you multiply by 2. So it's geometric.
Okay. Letter B. You guys remember what did we call the relationship
Okay.
when you added the
Letter
same
B,
number every
you guys
time?
remember, what did we call the relationship when you added the same number every time? Way back when. Was it linear, quadratic, or exponential?
Rise and run. We go
Linear, right? Isn't that what we do every time? It's like the rise and the run. We go up this much and right this much, or down and left,
This is
or
a
whatever you
linear
want to say, you know, kind of thing. The
relationship.
slope
A linear
tells you how much you're adding each
relationship.
time.
That means it's a
This is a
line,
linear
right? If you
relationship.
graph
A
it,
linear
it's a
relationship,
line,
that
okay?
means it's a line, right? If you were to graph this, it would be a line. Okay, and I'll explain how we can graph something like this, or how it would be graphed, because there's only really one set of numbers there. But anyway, so arithmetic is a linear
Here, we're
relationship.
multiplying the same every time.
Okay, going way back to that first unit. This right here, we're multiplying the same every time. It's
You guys go ahead and finish
exponential.
off D,
Okay.
E, and F there, okay?
All right, you guys go ahead, finish off D, E, and F there. Okay, give them a try. I'll give you like a minute here. Let's figure out if D, E, and F are arithmetic or not. Well, I guess I should just do that.
difference.
Remember, look for that common difference. Common difference. Common difference. Matt? Are we going to have homework? Yes, but it's not on here.
Come on, Matthew. Step up.
We're gonna have to do it anyway.
That's right. But don't go, I would say, go to this point for now. See if we continue.
Oh, wait, I'm sorry,
Yep. And if it moves.
This right.
Yeah, just find it setback right now. We'll do a little bit. Yes, it is.
I feel like this is so
Correct. I'm gonna check all those there. Very good.
It just looks
And this one, careful to minus 16 every time. It's going down. 16 is getting more negative. But it is still arithmetic though.
it's like this side has a weird 70.
One more minute. One more minute.
One more minute. One more minute.
D, E, and F, please.
What number did we go to?
D, E, and F, please. Yeah.
Wait, just D and F?
D, E, F.
Oh.
So be careful here. You go down three, but then down 4.
And then E
So
is
you gotta check them all. Yeah. And then E is correct. E is correct.
on F. Yeah, you can use that to help you.
On F?
I'll get into your calculator.
Yeah, you can use that to help you.
Okay, let's go here to Matt S. Matt S, what do you
Okay,
think? Letter D.
let's
Did you
go
get
here
it
to
arithmetic or
Matt
not?
S. Matt S, what do you say? Letter
Not.
D.
Okay.
Did you get it to be
Not
arithmetic or
What
not?
clued you in here that it was not arithmetic?
Not. Okay. Not arithmetic. What clued you in here that it was not arithmetic?
Aha. So it's not the fact that it's subtracting 3. That's okay. 'cause we can
Aha.
think about this
So it's
as
not the fact that it's
common
subtracting
difference.
3. That's
They're all
okay.
subtracting
Because
3.
you can think about this as, you know, that's a common
That's not
difference. They're
arithmetic
all
anymore,
subtract
right?
3. But then we go down
Not
4,
arithmetic because
that's not arithmetic
most are going
anymore,
down
right?
3,
And so not arithmetic because most are going down 3, but this one went down 4. It's got to be the same amount each time. So good catch there, Matt.
Live,
Well done.
Letter E, live. arithmetic
Okay,
or not.
let's go to live, letter E, live, arithmetic or not? Arithmetic, very good. What's the, how much is it changing by every time? Yeah, down 16.
Again, adding and subtracting the same amount each time. That's
Okay,
an arithmetic
so again, adding and subtracting the same amount each time, that's an arithmetic
Take
sequence.
volunteers for this one. Is this arithmetic
Okay,
or not?
and then last one here, letter F. I'll take volunteers for this one. Is this arithmetic or not? Daniel?
Okay, what's
Yes,
what's
it
changing
is
by every time?
arithmetic, very good. Okay, what's it changing by every time?
That's right. Okay.
Adding
Believe it or not,
1/6.
folks, These fractions.
That's right, okay? Believe it or not, folks, these fractions, add a 6th, you get 1/6. Add 1/6 to 1/6, you have 2/6, but it simplifies to 1/3. Add a 6 to 1/3, you have 3/6, but that simplifies to 1/2. Add another 6, you have 4/6, but that simplifies to 2/3.
One
Okay,
other
so
little
believe it or
thing I
not,
wanna
it
point
is
out here
arithmetic
before we
there.
move on to
Now,
notation. Okay, how to
one other
label
little
them.
thing I want to point out here before we move on to
Number
the
in an arithmetic
notations,
sequence.
okay, how to label them, is that this number in an arithmetic sequence, wait, let me go to the arithmetic ones here. So arithmetic, arithmetic, arithmetic. This number, shoot, these three.
These numbers
Sorry,
that-
these three
that
right
you
here.
add or
B,
subtract by the
F,
same
and
amount
E.
each time,
Okay.
that's called
These numbers that you add or subtract by the same amount each time, that's called the common. Common, not because it's like plain or everyday. Common because it's shared, right? Like when you have something in common with somebody else, you share that trait with them, you know, or you share that interest with them. These are all common differences. These numbers share these common differences, okay? So these are called common difference. Common difference.
common because
Okay.
it's shared by all the consecutive numbers. So like all of these are
Common
different
because
by
it's
negative
shared by all the consecutive numbers.
All of these are
So
different
like
by
all of
70
these are
positive
different
70.
by negative 16
All of these
in the
are
order
different
there,
by
right?
1/6.
All of these are different by positive 73. All of these are different by 1/6. They have the same common difference.
How to
So common difference is what it is.
label
It's
arithmetic
shared.
sequences.
Okay? All right. How to label arithmetic sequences. Okay?
Term.
So, the first term,
Okay. Or like when n equals 1.
okay,
Okay. First
or like when n equals 1,
the term is 1.
okay, the first term, or when n equals 1, that's the number of the term is 1. Question?
That's f of 1. The second
Yes,
term,
yes, go quickly. All right.
or
That's
when
f of
n,
1.
The number of the term is
The
2,
second
right?
term,
Second term or n equals 2, first term n equals 1. That's f of
or when
2.
n, the number of the term is 2, right? So second term or n equals 2, first term n equals 1. That's f of 2 in function notation. I'm going to put a dot, dot, dot. You get the idea, right? Third term would be f of 3. Fourth term would be f of 4, so on and so forth. The one we go up to is the nth
And that would be f of n.
term. Just n there. Okay, and that would be f of n. Okay, and of course it then continues on after that.
Is that n equals 1?
N equals 1, uh-huh. Sorry, handwriting
Going
is
beyond the nth term, you can have the n plus 1
not the best. Okay. And you can keep going beyond the nth term. You can have the n plus 1th term, the n plus 2th term, and stuff like that. Sorry, f is arithmetic, yes. Yeah, I got you for it. I got it for you there, Liv.
That number, when you identify an arithmetic sequence,
Okay.
the number
Kendall and Liv, also, were you here for the common difference stuff?
go up
That
by or
number, when you identify an arithmetic sequence, the number that's the same every time that you go up by or
There's another way
go down by
to
every time, that's called the common difference. Common because
or
it's
a
shared.
different notation, I should say.
Okay.
That sequence,
There's another way to
this one,
to
it would
show
be
a
when n equals
sequence,
1, you
or
have
a different notation, I should say here, and that's
For the
sequence
second term,
notation. And this one, it would just be for n equals 1, you would have a sub 1.
The idea, it would be a sub 3, a sub
For the
4,
second
all
term,
a sub n.
a sub 2. And then you get the idea, it would be a sub 3, a sub 4, all the way up to a sub n,
Okay. Beyond that. But we use that for
okay? And you can keep going, of course, too,
a sub 1,
okay?
sub
Beyond that. But we use that for sequence notation, okay? A sub 1, a sub 2, a sub n, so on and so forth.
So number 2 here then asks us to label the terms
Okay.
of the sequence and determine whether it is arithmetic.
So number 2 here then asks us to label the terms of this sequence
Okay, so we'll do
and determine whether it is arithmetic.
notation here.
If it is, find a sub 13. Okay, so we'll do function notation and sequence notation here. So we can say here that, this is f of 1.
F of
I'm not going to have enough
3,
space, I think, for this.
Very straightforward here. F of 4.
There's f of 2,
F of 5.
f of 3. You guys get the
Or
idea. I
if
mean,
you
it's
want
just
to
very
use the
straightforward here.
sequence
F of
notation,
4,
A sub 1,
f
A
of
sub
5.
2, A sub
Okay.
3, A sub
Or if you want to use the sequence notation, we can say a sub 1, a sub 2, a sub 3, a sub 4, a sub 5.
Is this arithmetic? What's the common
Is
difference?
this
5? We're adding 5 to
Is
10, right? Plus
this
5 plus 5
arithmetic?
plus 5 plus 5. So we want to find
What's the common
A
difference?
sub 13.
5. We're adding 5 every time, right? Plus 5, plus 5, plus 5, plus 5. So we want to find a sub 13. How should we do that then?
8 times 13.
What's that?
5 times 13.
5 times
So
13?
we have the 5th term.
Or 1. Yeah, I don't know.
Yeah. So we have the 5th term.
13 plus
Yeah, I think that would work. 5 times 13.
Because it starts
Or
at
actually,
Oh, I see what you're saying. Okay. Yeah, I think that would work actually.
66.
Yeah, I think that would work. 5 times
yeah, it's
13.
a little bit tricky.
Or actually, I think
We have
5
the 5th
times
term,
13.
We have to get up to the 13th term. That means how many more terms do we have to go up?
Yeah, it's a little bit tricky
5 to
here.
13 is how many more
So we
terms?
have the 5th term, and we have to get up to the 13th term. That means how many more terms do we have to go up?
So 8 times
From 5 to 13 is how many more terms?
40 plus the
8.
where we
So that's
started here,
8
21.
more plus 5s.
That gets
So
us
8 times
We're
5,
onto something there, and we'll talk
40,
about that.
plus the where we started here, 21.
And
That gets us to 61. Now, Sky, you were onto something there, and we'll talk about that. Okay? But I think that should be what we
yeah, 61 is the
end up being. I believe so. Times 5. Plus
You're
one.
onto
Yeah,
something, but
61
it
is the
wasn't
answer.
quite-
Yep.
and we'll talk about why that.
Okay, 61.
Right, turn the page.
You were onto something, but it wasn't quite. And we'll
Okay,
talk about why that
and-
is in a
Okay,
second.
we'll stop right there because we don't have enough
All right, turn the page.
We didn't get quite as far as I hoped to get today with that
Okay, and okay, we'll stop right there because we don't have enough time for that explicit rule. So we didn't get quite as far as I had hoped to get today, but that's okay. We will get into that tomorrow. It just means we'll have to cover a little bit more tomorrow. Okay, in the meantime, I do have a brief homework assignment for you here. Okay, I'm going to pass out a paper. Numbers 1 through 9 odd, okay, ID if arithmetic or not, okay. If arithmetic, describe the common difference. Okay, so basically, yes or no, if it's arithmetic. If it is arithmetic, then also further give me the common difference. Okay. So basically, yes or no to if it's arithmetic. If it is arithmetic, then also further give me the common difference. That's okay. You want to give Ella one real quick since she's got to head out. Sorry about that. 1 through 9 odd, and just identify if they're arithmetic or not. And if it's arithmetic, describe the common difference. Are we adding 5 every time? Are we subtracting 2 every time? You know, that kind of thing.